Welcome back, everybody. What you are going to be learning today is how to graph a line and then how to solve a system of equations using the graphing method. Just know that a system of equations means that I'm giving you more than one equation and I want you to solve it, meaning I want you to find out where they intersect each other. What's their point that they have in common? So just like a street intersection is when two or more roads cross each other, so like at, a light or a four-way stop. A graph intersection is just where two or more lines cross each other. We're going to look at this first, just how do we graph a line? So I give you the equation y equals 2x plus 3. I think the easiest approach here, since it is already in slope-intercept form, is to recognize what each of those things mean. So what is y-intercept? What is slope? Remember y-intercept, in this case 3, is telling you where your line crosses the y-axis. So if we draw this, I think this would be an excellent point to put the intercept down first. So let's pretend I have no numbers on my graph. I realize this. But let's pretend each of these lines goes up by 1. So like this is 1, 2, 3, 4, 5. This is -1, -2, -3, so on and so forth. Over here, since it says my y-intercept is 3, I'm going to put a point at 3. So we know for sure my line is going to cross through this point. You only need 2 points to create a line. So I could put a point over here and then I could connect them. I could put a point up here and I could connect them. So just know 3 is kind of like your starting point since we already had it in slope-intercept form. The 2, remember that tells you how are you moving to get from one point to the next. The first thing you're going to want to do is put that 2 into a fraction. That's going to make the most sense. Since slope is rise over run, we definitely want to write that 2 as a fraction so we know how much we're rising and how much we're running. So we can write 2 as actually 2 over 1 because 2 over 1 is the same thing as 2. So this really means that we're moving up 2 and over 1 to get from one point to the next point to the next point. So use that 3 that we started at and use your slope to tell you how to draw another point on the line. So if I start here, I'm going to move up 2 and then I'm going to move over 1 and that's where another point could be. You can draw more and more and more points this way. So from this location, you can move up another 2 and over 1. And then from this location, you can move up another 2 and over 1. And you'll notice that if you connect all of these, it will create a nice straight line. So let's do that. Notice though, these all cross, the line is touching all these points, but you need to extend your line. So continue it out because a line doesn't just stop between 2 points. You continue it until it, runs out of graph space. So unfortunately, my drawing tool does not come with arrow options, but there should be little arrows on the end of each of these to let the user know or whoever's reading this graph that it does go on forever and ever and ever. But this is how you graph. So think of your y-intercept as where you kind of start, and your slope is how do you get to the next whole number value. Okay? Here's another option that we have, also in slope-intercept form, so it's already in kind of this easy method for you. If it wasn't in slope-intercept form, get it there. It just makes everything easier. Another method, as you can see, is I have a little t-chart over here, x, y. You can actually pick values for x to plug in to find y values. So say I pick the value 0. Like, man, I really want to know what is x going to be, sorry, what is y going to be if x is 0? Well, you should already know the answer to that because if x is 0 and we substitute it in here, well, what's negative 1/2 times 0? Well, it's 0. So all that's left over is the 6. That's the concept of a y-intercept. So right here, it's telling you, all right, if x is 0, you're not moving at all, then y must be 6. So that's where we're going to put a point. So let's see, 1, 2, 3, 4, 5, 6. See how it says here, my y-intercept is 6? Well, we just discovered that. You could pick a whole bunch of values for x and plug them in and find out what you get. But in this case, since it's in slope-intercept form, it's easiest to just say, all right, what in the world do we have to do to get to our next point? Well, it says here our slope is negative 1/2. That means we are moving down 1 and over 2 to get to our next point. So if we start here, I'm going to move down 1 and over 2 and draw another point. Then I can move down 1, over 2 again to create another point. You really only need 2 points. I drew 3, but let's draw our line in order to figure out what our graph looks like. So let's see. I'm going to start here, but then show you what that looks like when I go the other direction as well. So this is what your line should look like. It does continue in both directions. You can use some type of ruler, piece of paper, something that has a straight edge on it to draw your line through these points. Just know you only needed 2. But that would be the line for y equals negative 1/2 x plus 6. This is where I actually want you to solve. So this is solving a system of equations if I give you, in this case, 2 equations. One is y equals 2x plus 1. The other is y equals negative 4x plus 7. So let's just graph both of them and then see if we can find out where they cross each other. I think that's going to be the easiest method right now. So over here, my starting point is going to be a positive 1. So this is where I'm going to start my graph, at a positive 1. That is right here. And then my slope of 2, remember we learned this earlier, write that as a fraction. 2 can be rewritten as 2 over 1, which means we're going to go up 2, since it's a positive 2, we'll go up 2 over 1 from that starting point. Up 2 over 1 from that starting point. Another trick, suppose you actually wanted to know, well, I want my points to go in this direction, Miss Jose. What do I do if I want them to go the other way? We'll just do the reverse. So instead of going up to right 1, go down to left 1. Down to left 1. It's just the complete opposite to make you move in the other direction. But those points are also valid. Notice how it does go with the flow of that line. So I'm going to connect all of those with my line. See, down 2 over 1, down 2 over 1, about here. Okay, I'm going to use a different color for my other equation. Let's do, I don't know, say blue. This one here says our starting point is going to be at a positive 7. So that's going to start a little bit higher up, but notice how my graph actually has a negative slope. So 1, 2, 3, 4, 5, 6, 7. Did I do that right? 1, 2, 3, 4, 5, 6, 7. Yes. So I have positive 7 here, and then my slope is negative 4, which means I move down 4 over 1. So 1, 2, 3, 4, 1. And I'm only going to use the 2 points here since you're learning that you only need 2, but you can draw more if you want. And I'm going to draw my line. So if I draw my line through this, you'll see here, I already have the point at which they cross. That is what I'm looking for, the intersection. So where do these two lines cross each other? Well, we move over 1, up 1, 2, 3 to get to that point. So that happens to be the intersection. We went over 1, that's our x value, and we went up 3, that's our y value. So that would be the intersection. All right, let's do one more example of this. This one here is 3x minus 3 and negative x plus 9. Again, both of them are already in slope-intercept form, which is great, so there's really no reason to use the t-chart. I only use that if something is a super big, scary equation that you don't want to have to solve for a single variable. But here it is telling us that our first equation starts at, be careful, it is not 3, it is actually a negative 3. So that is where we're going to put our first point. So I'm going to move down 3 for our starting location. Then our slope is 3. That means, since it's a positive 3, we are going to move up 3, 1, 2, 3, and over 1. And those would be our 2 points. And again, just go ahead and connect those with a line. Let's see, I'm going to, hold on, it's being picky. There we go. Let's see here, and it extends a little further down. Apologize for that little cut in the line there. Let's do the other one in green. This one says we start at a, we start at a positive 9. So that one's pretty high up. This graph goes up to 10, so I know that that's my point at 9. That's my starting point. Negative x, think of that as negative 1x. Remember, if you don't see a number there, there's an invisible 1. So this is a negative 1x, which means we're moving down 1. And we can rewrite that slope as a fraction. So this could be rewritten as y equals negative 1 over 1 x plus 9. I wrote it as a fraction just so you could see the rise over run. So we're moving down 1 over 1, down 1 over 1, down 1 over 1, repeatedly, over and over and over again. So I'm going to keep doing this until I hit my other line. Down 1 over 1, down 1 over 1, down 1 over 1. So we have found where it's going to cross, but I still want you to be able to draw the line. Make sure there's arrows on the ends. So right here, I want you to be able to tell me what point that is. Remember, it's x, then y. So my point of intersection here is going to be, let's see, 1, 2, 3 is my x value. And then my y value is 1, 2, 3, 4, 5, 6. And that would be your point of intersection. So that's how you graph lines, and that's kind of the easy method. And then how in the world do you find out where they cross each other? Using a graphing method.